is there a problem? I'm sorry, I have to stop that. Is there a problem with the sign in? You don't have to sign in or sign out or back again. If you can hear me okay, just keep doing that. Okay. All right. So good morning, everyone. The session today is about working with Web of Science and Scopus. And thank you very much for attending this webinar during a snowy day. I know everywhere is blanketed with snow right now. So thank you for staying indoors and joining me with this little discussion and demo. Okay, so for today, if you still cannot hear anything, please just try to dial in with your phone. But if you're doing fine, just keep doing whatever you're doing. Okay, for the course objectives, we hope to be able to gain an introductory knowledge about the concepts and methods used in bibliometric analysis, and know what are some available features existing in either Web of Science and Scopus, and then understand which tool to use to meet your specific needs. Because there are times one is better than the other, or one is more appropriate than the other. Okay, so I'm going to quickly go over the introduction about bibliometrics, just like 2 minutes, refresher, and then show you some of the examples, again, very quickly going over that. And then we're going to talk about how we can get data in and out of Web of Science, some of its major features, and same thing for Scopus, and then we'll be doing some practice together. Okay, so for bibliometric analysis, as I mentioned the last time, it's a set of qualitative methods to analyze scientific research using publication as a proxy for research. And if you still remember, I focused on 2 things. One is that it's quantitative methods, so we're going to see a lot of numbers. And the second thing was that we have to see the publication, focus on publication, so look at publication data. Okay. And just a quick reminder about publication data. So usually we will see authors, article title, journal, volume, publication date, things like that. But when we pull out the data from the vendor database, we're going to see a lot more. And among all of the things that I listed here, what is most important to us when doing bibliometric analysis is probably citation count, because that is the number that people want to use when they do additional analysis. Say, for example, they wanted to know the relationship between citation count and any other of these variables listed in here. Okay, so these are all of the things that we can get from either directly the website or the metadata that they provide. Okay, and another thing that I'd like to quickly go over is about the capacities of bibliometric analysis. So there are a lot of things bibliometrics can do, but for the scope of our training, we're going to focus on the things that we have done a lot, especially the core report or the IC report that we provide to each of the institutes here at NIH. So some of the major things that you see maybe tons of times already is that when we push out those IC reports, you're going to see something about the productivity. So basically, it's publication count about a lot of different things, by document type, by particular year, by Web of Science subject category, by journals, okay? And you will also see the collaboration patterns. So there is the level about the institution. There is also something about the research topics. So what are their major research topics? And finally, about their citation impact. So these 4 major areas are the things that we do a lot in our reports. And these are also the things we wanted you to be familiar with. So today I'm going to focus a lot more on the first part about productivity. Okay, and we'll also be able to covering a little bit about maybe research topics, not that much actually, okay, and some about the citation analysis, all right. So that will cover at least like 1/4 of our major analysis done in these IC reports. Okay, so let me go to Web of Science and Scopus, the tools that I'll be covering today. So the first thing is that it's about the two general tools that we use. The coverage, okay, so for Web of Science, it's about more than 20,000 journals. And Scopus, you can see that they have slightly more journals. And for the coverage, Web of Science have actually 73 million articles right now. And Scopus slightly, okay, basically slightly the same, but smaller number of publications. And you can see the time coverage is different. Okay, so Web of Science goes much deeper, way back to 1900. But for Scopus, it's newer, all right? And you can see that their citation reports also have different coverage. And you can see that they have different reports talking about their content coverage and what are the things that they collect. So what is available on their website? For Web of Science, we can get a lot of basic publication data. We can also get essential science indicator top papers. So there are the highly cited papers, there are the hot papers. So for the highly cited paper, basically it's the top 1% of the papers by citation in each specific subject area in essential science indicators within the same year. And for the hot papers, it's even a smaller number. So it's the top 0.1% by citations received in the most recent 2 months. So you can see that they look at publication citations, very new citations, but only look at the publication that has published in the past 2 years. Okay, so what they are looking at here is to see if there is a spike of citations for some of the new publications. All right. They also talk about what kind of articles published in open access journals. They also provide metadata. Whatever they collected, they provide. It's just that you will have to download the data 500 records a time. They also provide citation reports if the records that you submit or that you search is less than 10,000 records. Okay, so what is included in the citation report are number of papers, citations per year, and you can look at the self-citation count when you do a little bit of a math. You can also look at H-index and citing articles. Scopus, you can see that basically they cover almost the same thing. So you have basic publication data, you also have metadata. It's just that they do not provide links to top papers or highly cited papers. They do not really do that. Okay, but for the metadata, they have their restrictions or limits as well. So for the metadata, your search has to be smaller than 2,000 articles. If your search, your data set is smaller than 2,000 articles, the entire available data can be downloaded. If it is larger than 2,000 records, you will have to send a request, but they are going to send you only the first 20,000 articles with basic data. So it means that if your data set is larger than 20,000, they only will give you the first 20,000. And it's not a full data set, it's only the basic data. So if your data set is larger than 2,000, a better way is probably to slice your data into different chunks so that each chunk is smaller than 2,000, and then you can aggregate them together to get your numbers. Okay. They also provide you with the numbers of which articles are published in open access journals. They also show you the citation overview. Again, the limitation is the magic number of 2,000. So if your data set is smaller than 2,000, Then they're going to show you the number of articles, citation per year, sub-citation, edge index, things like that. So basically very similar to what Web of Science can provide. Same thing, if it is larger than 2,000, then you will have to request, and then they will send you data about the first 20,000 records. So if what you have is larger than 2,000, again, my recommendation would be to slice your records into chunks of like less than 2,000 and then aggregate them together. But one difficulty that you can probably imagine right now is how you're going to put all of these things together. If it is just publication count, it's easy. You can just add them together, and then when you have different chunks, you just add them together. But how about edge index? You're not supposed to add all of those edge index together, right? So that can be quite challenging when you have several different data sets and you like to aggregate them together to get edge index from Scopus. All right. So basically, these are what is being covered in Web of Science and Scopus, and I have also quickly go over some of the limitations of each of the databases. All right. So now I want to go to Web of Science first, because actually that is the one we use most heavily in terms of our data resources. So we get a lot of our data from Web of Science. One thing is that it actually has a much deeper coverage. So whenever we'd like to do something that goes beyond 1970s or something that you would like to see over 30 years, 50 years, you want to use Web of Science data. Another thing is that we think Web of Science data is slightly cleaner than the data in Scopus, especially in the field of funding agency and affiliation. Okay, anyway, so I'm going to start with Web of Science today. I'm going to quickly show you some features with a snapshot first, and then I'll move on live, okay? All right, so Web of Science, what does Web of Science have to offer, especially when we are doing bibliometric analysis? The first thing is that they offer us with a citation report. They tell us some of the very easy, straightforward, basic analysis that you can just copy and paste or download, make your own graphs, or just use their graphs, okay? They also provide you with publication metadata. Okay, so when you go to the Web of Science webpage, there are some features that I'd like to highlight right now. So the first thing on top is that you can see there is a usage count, okay? This is something kind of like alternative metrics. So it doesn't talk about citation, and it has nothing to do with citation. Basically, it is something Web of Science track on a daily basis to see how many people download or save an article from their website, and they provide or update this number up in here. So here you can see the usage count. Okay, so for papers that are very new, or they wanted to see their impact, we usually encourage our users to use this usage count instead of looking at citation. As we know, paper needs to be at least 2 years old to accumulate enough citation to do citation analysis. So for publication that was just published maybe last year or last month, we would rather looking at the usage count instead of the citation, because we really need to wait to look at the citation. But again, whenever we use usage counts, we also have to warn our users that it really has nothing to do with citation. High usage count doesn't mean that you will be highly cited at all, okay? And we don't really know if people, how people use this kind of downloaded or saved. People may download it, may save it. It's kind of an indicator of interest, but it doesn't really mean they have read it or they're going to cite it. Okay, so this is the first thing that I would like to share with you. The second thing is that there are 2 tabs here, okay? The first tab is about creation citation report, and then the second thing is about analyze results. So I'm going to show you both of them later. So when you click on that, you're going to see different features. Okay, The third thing is that once you have your data set searched and you feel that this is the data set I'm going to work on for the following analysis, you can save it to other formats or save it to insights. And I hope all of you have tried that you have access to insights already. And if not, please do talk to either Lisa or Rebecca to make sure that you have access to insights. Okay. When we use the feature save to other file formats, it's always because that we would like to download metadata from Web of Science. And I'm going to show you how to do that later. So these are the, some of the features that I hope you will keep in mind, and they can be very handy when we're doing bibliometric analysis using Web of Science. Okay, so for Web of Science report, remember the two tabs that I showed you earlier? So if you click on the Create Citation Report, you're going to see an overview, something like that, okay? So this is just a data set that I quickly pull out. So you're going to see the total publication, the average, the H index, and please remember that the index, H index here is not the average index of all of the co-authors here in this data set. It has nothing to do with the average, okay? It's only showing us that 148 articles in this data set has been cited at least 148 times, period. Okay, so this is how we interpret H-index when you are looking at a specific data set, usually not by one single author. If it is one by single author, and if it is all of his or her publications, then this H-index is his or her H-index. But a lot of the time, I would say that 90% of the time when we do analysis at NIH, the total publication is the total publication of a group of people. Okay, so we have to make sure that people understand that it doesn't mean the H-index here is the average H-index of all of these co-authors. It's not. Okay, so and here you will be able to get the total citation count. And this is a number without self-citations, meaning that if there is no self-citations, the citation count would be this much. And you can see that this is a huge difference, all right? And usually we do not want to see something like this. You don't want to see something that has a lot of self-citations, but there are exceptions. The exceptions are when the topic is really new and the research is being done in a very small group of people. So just imagine the topics of like Ebola or Zika. So the topics are really new and only a small group of people working on that. So when they first push out their research, they will have to cite their own research to build up whatever they have done already. And that's why when you see something that has such a dramatic number, you will have to take consideration of their research topics. And I believe this one is about Ebola. Okay, so you can see that because it is really new and only a small group of people working on that at that time, they have to cite a lot of their previous work or their original work. Okay, so they have a lot of self-citation rate. And how do you do the self-citation rate? So it's easy. You just use this number minus this one, and then the denominator would be the original cited citation count, and then you will get a rate. Okay, and that rate would be the self-citation rate. Okay, and here are the citing articles. Usually there is a link, and then you can click on that, and then you can see what are the articles that cite these data sets. Okay, it actually would be very interesting to compare the original data set and also the citing articles, especially when we are doing impact analysis. There are times you want to see if these publications, these two sets, the original one and the citing article one, if they both publish in maybe the same country areas, okay, and you may want to look at the kind of journals they publish, they appear. You may also want to look at the subject areas they appear. So that's a different way to look at the impact. Maybe that if the original country, original data set only focus on, they're majorly published by author here in the United States. And if you find that the citing articles are usually from maybe Africa or Asia, you can say that this is another evidence of the impact showing the spread of the research impact, okay? And you can also say that if the research in the original data set is mostly on, say, the immunology, and then you find that the citing articles, the major areas is about public health or even something else, again, this is something that you can argue that your original research has spread the impact from the maybe basic science to the more implication ones, translate to the public health or the policy, something like that. So there is a way to see the impact of your research by looking at the citing articles, not just by looking at the citations, but looking at the citing articles. And again, in Web of Science, when you click on citing articles, there are similar other things that you can do. You can look at the journals, the author, the subject areas. So the same thing that you can do for the original data set, you can do it for the citing articles. All right. The next one that I would like to show you is about the citation per year per article. That is the same thing you will get under the tab of Create Citation Report. So if you download that, you will be able to get all of the articles from your data set and then to look at the citations they receive each year. If it is something of interest to you, you can download that. Okay. Another thing is about the basic analysis. So for the basic analysis, you will have to click on the Analyze Results tab. Okay. So basically what you're going to see is something like this. Okay, so on the left, you're going to see Web of Science subject category, publication year, document type, a lot of things that you can click, and then new things will pop out here. And here, the visualization, there is a little triangle here. If you click on that, you can choose different types of visualization. Okay, they also give you the flexibility of selecting the results. Do you want to show just the top 10, top 15, top 5? You can do that. And then you can update the graph. You can also download the graph. Okay. And there's a little table here that you can download as well. Okay. All right. And then the next thing is the usage count that I have shown you already. So when you click on the usage count, you will be able to click on that and then sort your publication based on the usage and see what are the papers that have been downloaded or saved most during the past 180 days. Okay. We also have things about metadata. Okay. Web of Science provides a lot of ready-made features already, but it's not enough for us. A lot of time we have to do more. Remember, we do a lot about collaboration. We want to see the patterns. We want to see the funding agencies. We want to use their data, maybe, for example, their titles to do text analysis. So these all lead us to the need to download all of the metadata to do additional analysis, okay? So when we have the search results, you have to put in this little triangle here and drop down and click the one that's saved to other file formats. Okay, and it will show you several options that you can pick, and I'm also going to show you later. So it depends on the needs of your analysis, you can choose the specific file format that is best for you. Okay, and then you will be able to download the metadata of the publications. The warning is, as I mentioned, you will have to download 500 records at a time. And then if your data set is larger than that, you will have to put them all together, either copy or paste, or use some command line to do that. Or I know that Chris has his API developed already. So if you have data set that is larger than 500 and you don't want to download them 500 at a time, 500 at a time, you can talk to him. I believe he will be happy to help you with that downloading. Okay. So let's just pretending that we have an easy data set that we have downloaded already. This is what you're going to see. Okay. So originally it will be sort of like a text file, but when you open it and paste it to an Excel, it will be like a spreadsheet, and you will get a lot of different fields. Okay, and for those tag names, it's searchable. So if you just put in field text, Web of Science, I believe the first choice from the Google search results is this link. All right, so they will tell you that author, AU is the author name with initial, AF is the author's full name, TI is the title, SO is the source title, that's the journal title, there is LA language, there is document type, there is abstract. CI is the field that we use for affiliation. So I believe when we are doing data cleaning next week, we will be using the data from this field, okay? Talking about how we can extract affiliation from these specific columns. And you will see that if we click on that, you will see there is author name, there is author affiliation, there is city, country, and sometimes zip codes. So there are a lot of things in this specific column, but what we need is usually the specific affiliation and sometimes country. So this is a time that we need to do a lot of the cleaning, okay? FU is about a funding agency. This is important when people would like to know what funding agencies fund the research or co-fund specific research. And we have, again, we have to do a lot of cleaning for this as well because of the different creative way people cite or acknowledge their grants or the funding agencies. Okay, TC, time cited. So this is the part about how many times the article has been cited when you downloaded the data. U1 and U2, I don't quite remember, I believe it's usage count. This is about the last 180 days. This is, I don't quite remember, I'll have to check again, but it's the usage count. Okay, and then there's about the publication year. WC, again, it's another field that we use a lot. It's the Web of Science subject category. Okay, so we use this category to look at, to do some very basic topic analysis. Okay, and here is UT, so that is the Web of Science accession number. So for each of the article indexed in Web of Science assign them with a number, and that number is unique to each of the article, but only, I would say that it's only important or usable in Web of Science because you won't be able to search that number in other databases. You won't be able to use this number to search in Scopus or use this number to search in PubMed. No, you won't be able to do that. Okay, but you can use this Web of Science accession number to search articles in Web of Science and in other related tools that is associated with Clarity, like Insights. Okay, TN here is about PubMed. So you can see that PubMed is actually a more important number comparatively because this is a number you can use across different platforms. You can use PMID number to search in Scopus, in PubMed, in Web of Science, in Embase. So you can use PMID number in almost all the databases that we can get access to right now. All right, and here they talk about if these are open access journals. Okay, they also show you the different levels of open access. All right, if they're highly cited paper, if they're hot paper, so you can get all of these information in one file. Okay, it's just that you will have to be patient to download them and know the tags. And as I mentioned, the tags are in here. All right. Okay, so how do we get data in Web of Science? And I know that all of you are really good at searching, so I'm not really going to focus on that part. We can do author search, we can do affiliation search, we can do the PMID number search, okay, we can do a topic search, okay. And when we get data out of the Web of Science, again, we can save it to other file formats, 500 records at a time, or we can also save it to Insights when you want to do additional analysis or get something directly from Insights. All right. So this is a very quick overview about the features that we usually use in Web of Science. And now I wanted to move online to show you how exactly we can do that. All right? Okay, so let me close this one first, and I'm going to show you Web of Science. Okay, so this is Web of Science web page. When you go to the library website and you click on the resources that we have and then go to Web of Science. The first thing that you would like to make sure is that you go to the right database. Web of Science has a lot of different databases you can see, okay, but not all of these databases works well with citation analysis or bibliometric analysis. So please make sure that you go to the core collection, because that is the only database under Web of Science that cross the citation and cross all of the things that we need for bibliometric analysis. Okay, so this is the first thing that we have to keep in mind. All right, now we can do a lot of different searches here. You can do the basic search, you can do cited reference search, you can do advanced search. A lot of the time we just do advanced search because it gives us a lot more flexibility in searching the things that we have to, in searching the publications that we have to do analysis on. Okay, but today let me start with a very basic search. Say, for example, if we wanted to do something about Zika research, okay, so we just do this quickly, and you can see that there are only 6,000 something articles altogether in Web of Science. Okay, before I go any further, I will always go to the Analyze Results part to do some very basic trimming to make sure that this is a data set that I can work on. Okay, so say, for example, let's look at document type. If I click on this document type, okay, and again, as I mentioned, that there is a visualization. You can do different, you can pick a bar graph, you can pick tree map, okay, and you can also change the results. There's different thresholds, 5 or 10 or 15, and then you can modify that. All right, and here is the table that you can download if you would like to do your own chart or graph. But before I go any further, let's take a look at all of the document types being displayed in here. So there is the original research, there is the review, there's editorial material, there's meeting abstracts. So these are just abstracts submitted to conferences and meetings, so they are not full text and they do not have citations. So whenever I do bibliometrics analysis, this is the first thing that I will exclude. Okay, there's no full text on that, there's no citation on that, and it is just abstract. I don't consider it as a complete research. Okay. There's also letter, news item, preceding paper, correction, book chapter, book review, data paper, early access, reprint, retraction. And you can see that retraction is another thing that you want to exclude. All right? Okay. So these are the two things that I will always exclude. And when our number dropped down a little bit, especially because we removed the meeting abstract. Still, I'd like to take another look about the things that is being included here. Okay, remember we talked about that different types of documents actually have different citation accumulation rate. So compare with original research, reviews actually have a higher citation accumulation rate. So some people actually argue that if you, when you're doing the bibliometric analysis, you don't want to include reviews because their citation rate or their citation count usually are higher than original research. So this is something you would like to sit down with your clients and ask them and tell them. You have to let them know that there's different citation accumulation rates of the different types of document types. Do you want to include all of them, or are there specific types of research documents that you would like to include? Usually, my clients would say that they don't really care. As long as it is something legitimate, they will include it. But there are also times my clients will be very clear saying that they only want research articles. They don't want anything else. Okay, so it's possible. So make sure that you discuss with your client before you go any further. All right. So for this one, let's say that we want to focus on article, review, editorial material, letter, preceding paper, book chapter. I'm just picking up something. All right. Let's focus on these things. So this is the first round of trimming, making sure that these are the right document types that I would like to work on. Okay. The second thing that I can do is now I will go to the analyze fields again to look at all of these things. I can look at the specific Web of Science subject category. Remember that Web of Science assign specific subject category to all of the journals that they index. And each journal can be assigned to more than one subject category. So for whatever articles appeared in that journal, they naturally inherit those subject categories, okay? And because one journal can be assigned to multiple subject categories, you will see that if we click on that, and if you add all of these things together, they won't match up to the original results. It's because there is double count, okay? Articles appear in infectious disease, may appear in public health as well. So there will be double count. And again, this is something you would like to explain to your users or clients, letting them know that how these categories are being created and how they're being counted. Okay, there is also something about publication year. Okay. So here you can see that from 2010 all the way to 2019, okay, and there's a peak in 2016. It's because the outlet was is 15 and 16, so it makes sense, right? Okay, so when you look at the trend, you will see that it has very little publication before 2016. And then a lot more publication during 16, 17, 19. It makes sense for us to understand the publication trend because when the specific disease has the outbreak, okay? So it's also important for some people who would like to see, for example, the the trends of the research, or maybe the specific subject area that has been published, or maybe specific organizations that has worked on this research, or the funding agency, or the authors, or the specific journal titles. So that would work for most of the analysis here, okay? But one challenge is that if we would like to do citation analysis, we actually will have to crop out a lot of publications because publications have to be at least 2 years old to accumulate enough citations to do analysis. Okay, so let's look at this data set again. We have a lot of publications from 16, 17, 18, 19, right? And it's only the beginning of 2019. So if we would like to do citation analysis on this specific data set, it means that we actually will have to crop out at least 17, 18, 19. Okay, these articles are really too new. It's really not fair to include them for citation analysis. Okay, so my point here is that if you just want to do analysis on maybe a time trend, or maybe on topic analysis, on journal analysis, on affiliation analysis, on collaboration analysis, you can include everything up to the current, and it's valid analysis. But if you want to do citation analysis, you will have to crop out the publications that are very new. Okay, so let us exclude that here. And you can see that the number dropped down dramatically from 6,000 something all the way to less than 2,000. Okay, so now this is the time you can go to the Creation Citation Report to look at the citation analysis part. Okay, so you can talk about the total publications you receive, the data set received from like 1955 all the way to 2016. Okay, and their average citation, their H index, and again, the H index only means that in this data set, 120 articles have been cited at least 120 times. Okay, and then this is the total citations that can be retrieved from Web of Science without self-citation. So if you want to do the math right now, okay, you just pull out your calculator. This is original citation count, right? And we want to, this is the citation without self-citations. Okay, so let's do the math. Minus 45279. So you can get that this number is actually the self-citations, meaning that the author, the co-authors, the author and the co-authors here in this data set, okay, cited their own publication these many times. So this number divided by the original one, okay, it's almost like a 24% is the self-citation rate. And as I mentioned earlier, usually the self-citation rate is between like 2% to 20%, and we take it like a normal way. So anything beyond that may be skeptical, but Zika or like Ebola is so new, so it really makes sense that they have a lot of new citations or citations from their own. Okay, so we take it, so I would think that this is quite normal. Okay, so this is how you can get self-citation rate. And these are the citing articles. As I mentioned that if there's a link, you can click on that, and you can do further analysis. Okay, you can see when are these articles, when did this article appear, what are the specific subject category, are they the same as the one that we have just searched, what are document type, what are the organization, things like that. So there are a lot of things that you can compare through this link. Okay, now let me go back to the search that I have. Okay, I want to use advanced search, and this is the last data set that I have about Zika. Okay, and then I want to go back to the analyze results thing here. We have the Web of Science subject category, we have the publication years, we have the document types. Remember that you can always download these things. Okay, so you can click download, and you can also change the record here, the threshold. You want to have 100 or anything. So these are the things that I picked, so we only have these, so it really doesn't matter. So you can download it. Once you download it, it will be like a text file, and if you copy and then paste it to an Excel, it will be something like this. Okay, I don't need these things, I'm just cropping it out. Okay, so you will see that it shows us the article, the records, editorial material, the letter, review, preceding paper, book chapter. And now let me remind you again about the things that we'll do. Remember, when we are producing these reports, I want to go back to here. Okay, so this is the first thing that you will like to create when you get the document type. Okay, and then you can do this for the publication trend, Web of Science subject category, the publication per journal. Okay, so just a reminder, what are the things that we're going to do? And I'm switching back to Web of Science and also the data set that I just downloaded. Okay, so here once you have the data set, it's pretty straightforward. Okay, so in Excel, you just select the data you have just put in and then insert. So you can see that these are just the charts or the graphs that we use a lot in our reports. Okay, so for this one, we usually use a donut chart. Okay, and there are a lot of colors, and we want to make them just different shades. Okay. And then we can do slightly modifications that, first of all, we want to add the labels. So the label here is only the records. It's not what we usually see, right? But you can modify that. So we can format the data label saying that we want a category name, we want a percentage, and it's very busy right now when we have all of these label and number and percentage. So you can click off value. So now you have only label and percentage. And it means that this one is redundant. We can take that off. Okay, so here we have something that is very similar to what we are doing already. And you can still do something to modify a little bit. Say, for example, you want to make the donut a little bit fatter. Okay, so we can change the percentage here. Make it either, say, like 60%, so it will be fatter, okay? Or if you want to rotate it a little bit, you can change the angle here. Say, like we change it to 60 degrees, and then it will rotate slightly like this, okay? If you're still not happy about it, you can drag select one of them and drag it out so that it wouldn't be so busy. Okay, or if you would like to change the color here, you can go here, select one, and then change it to white. And after that, we usually do not need border of it, so we'll pick no line, we select it, and then you can just, if you think this is what you would like to do now, you just copy it and then paste it to a Word document. We'll share with you a template that we use a lot, so whenever you're done with your analysis, you can just copy and paste your new chart to the template that we have. Okay, so this is something that we do a lot for the document type. Okay, I also want to show you about the journal titles. Okay, so here you can see that there are tons of a journal that you can see. You can try to use 100, 250, 500, depending on your goals. Okay, but usually for visualization purpose, we just list maybe the top 10 because it would be too busy for people to see all of the journals in this data set. Okay, so we'll just list the top 10 here. Okay, so these are the top 10 journals. And again, you can just download it here and then copy and paste it. I'm going to use a different tab sheet here. All right, the percentage is not important to me, so I don't need to use that. Okay, these are the top 10 journals. Okay, and for the journals, we usually just use a chart, a bar chart to do that. So what you want to do is that you want to sort them again from the smallest records, from the smallest to the largest, okay? And then you can insert and then do that. Okay, we don't need this one here. And you want to make the chart, the bar, a little bit fatter, okay? So again, change it to a different number, maybe 50. I usually use 50. Okay, so here you can see that we have something very similar to what we present already. It's just that there are times you will see that these names are too long and it won't be displayed appropriately. Okay, so there are two ways you can modify that. One is that you may want to try to make it smaller font say maybe 7, and see if that works. Okay, so in this case, it worked, okay? And then you can just copy and paste and then to your document. There are also times that even when you use smaller font or when you think that the font is really too small, it's not visually appealing or readable, then you may want to use abbreviations, okay, to show these journals, all right? And again, after you're done, you copy and paste to the template. Okay, all right. There is something about organization enhanced and organizations. So remember last time Candice talked about that Web of Science actually is in the process of unifying and cleaning the organization in entities. Okay, so let's take a look at the difference of these two organizations and organization enhanced. So if you click on organizations, you will see that, let's show more. It will be much easier for us to update. Okay, so you will see that there is CDC, okay, there is another CDC, okay, if you scroll down, I believe there is several more other CDC. So you can see that the data here treats each of these different names as different entities. But if you click on here, Organization Enhanced, they basically have done the cleaning already for us. So you will only see one CDC here, okay? One CDC, and you will only see one National Institute of Health. I'm sorry, 1 second. Okay. So using Organization Enhanced will give you a more unified or cleaner data if the institutions that you worked on have been cleaned. Remember, they're still in the process of unifying or clean these affiliation names. If the affiliation names haven't been cleaned yet, you won't be able to get the right data here in the organization enhanced table. But for our purposes, it works pretty well for us. So if you want to get a quick table about the affiliations working or support this kind of a research, you can use this table. Okay, same thing, you just download the table and then build up your own chart. All right. There is a part of funding agencies. I always just use the metadata instead of the table because, as you can see, it's not clean at all. There's NIH, there's National Institutes of Health, there is National Institutes of Health, NIH, and you know that they're all the same. And so basically this table is not really helpful. Okay, so I only use the metadata instead of the raw table here. There is also the part about the country. Okay, so this is the data that you can download if you would like to create a map about the country, talking about which country is conducting the research. So you can use that, okay? Or if you just want to build up the table, this is the part that you can use. And then we also have other things, but I don't think they're quite important. Okay, for authors, again, not clean. Okay, so you're going to see author with middle initial or without middle initial, and they can be the same person. So you will have to do a lot of cleaning as well. So I never use this table. Okay, all right. So these are some of the major features that you can use easily from Web of Science. But please also make sure that you know what features are cleaner or better than the other. All right, so these are the major features that we can get from Web of Science. Let me go back to here. Okay, and then after you're sure that these are the things that you would like to work on, and then you want to do more analysis on the metadata, one thing you want to do is actually to download all of the things. Okay, so when you want to download all of your the metadata of a specific data set, you want to save it to other file formats. Okay, and remember, you can only do 500 records at a time. So let's do like 1 to 500 here, okay? And for the record content, make sure that you select full record and the cited references. This is especially important when we want to do topic analysis through Web of Science, okay? So make sure that you select this one. And then for the file formats, if you click on that, you will see that they actually provide you with a lot of options. Okay, there are different things that you can pick. If you just want to get a quick spreadsheet, I'm not talking about other tools, okay? If you just want to get a quick spreadsheet, please use these tab delimited. Okay, if you use Windows, click Windows. If you use Mac, click Mac. So say, for example, that we want to use Windows. So we just click on that and then send. And then Web of Science will actually download the file directly to either your download folder or any folder that you assigned it to. Okay, so when I open it up, you're going to see tons of text, and it doesn't mean anything to you at all. Okay, but if you select copy and paste them to an Excel sheet, does it look familiar to you? Yeah, so it's the whole metadata that I shared with you earlier. Okay, so there is some, okay, you don't have to care about this one. So there is the author with the initial, there's the author with the full name, There are other texts that I never use, so I don't know what they're for, okay? They're about title, the journal source, the language written, document type, abstract, and CI. Remember, this is the column that we will be using for data cleaning, for the author affiliation. So let me show you the format of this specific field. So you will see that the way they structure this column is that they put all of the authors from one specific affiliation together into a bracket, okay? So these are all the authors from these specific affiliations. So usually affiliation, and then city, and then country. And here, again, same thing. Another author's affiliation, city, country. Okay, let's see if we can find something else. Okay, so here, same thing, okay? Authors, affiliation. Okay, sometimes they go down to lower level, like which school. Okay, so this is university, a specific medical school, even building. Okay, and then the city, and then the country, and even the zip code. Sorry. So you can see that when we do our network analysis, usually we just want to use the agency or the affiliation here. We don't need anything else down there. Or there are times we want to focus on the country here and see which country works together. So you can see that we have to do a lot of cleaning in this field, and Candice will be covering that next week when we are talking about how we can use Refine to do this kind of a cleaning. Okay, and you can also get other information, reprint author, their emails, the funding agency, the text, funding text field. Funding agency, as I mentioned, very messy. Again, you have to do a lot of cleaning because of the different ways people acknowledge their grants. Okay, time cited. So this is the number that you should use for all other analysis that has to do with citations. Okay, and then as I mentioned, there's a publication year, and then there's also the Web of Science subject category. Okay. So this is if you just want to work with a spreadsheet and you're not going to do something particular fancy. Okay, but there are times we actually have to do more, especially when we do the network analysis. They require a different file format. Okay, so in that case, we have to save it to other file formats. And now it doesn't let me, so you have to click on something else, close it, and then save it to other file formats. Again, let's do 1 to 500 again. And remember to pick for record and cited references. And this time, you don't change anything here. Just let it stay as other reference software. Okay, and click send. Okay, again, Web of Science is going to download this record directly either to your download folder or to a folder that you select or assigned. Okay, if I open it here, you will see that it's tons of text, and it probably looks very similar to to another document that we have just seen. Okay. You can open it up with other text editor, and you can see how it's structured, but it's not what we're supposed to do right now, okay? To make more sense of it, or to make it working for us, what you're going to do is that once it is downloaded, you want to change the file extension. So go to File and click Save As. Save it to a place that you will remember. Okay, I'm just going to make it to all file, and then I'll say that this is the test file. Change the file extension to ISI. Okay, I want to stay here for a little bit while so that you remember, because it's very important you get the right format. Okay, so you can name the file whatever name you want, but do remember to change the file format to .isi, okay, and then save it to a place that you remember. Okay, now this is a file, this is a .isi, okay, and I want to quickly show you how we can do with that. Chris and Candice will probably talk, we'll talk more about that, but I still want to show you what we can do for it so that you will understand why it's important to us to save it in this way. Okay, I'm also assuming that you have Citation installed already. Okay, so when you open up a Citation, the first thing that you have to do is that you're going to load the file. Okay, so we're going to load the file that I have just saved on my desktop. Okay, the test file. You're going to see some of the red print. It doesn't really matter. It's just something that has, it's just that these fields are being created after Citation has been invented, so they don't really recognize these fields. So it's all right. Okay, so this file has been loaded already. Okay, and you can also see that here it says that there are 490 ISI records, meaning that we saved 500, but only 490 of them have been recognized. All right, and again, it's fine. So if we right-click on that, we can actually view these records. And you can see that it's another spreadsheet. All right, and here you can see that there's abstract, there's author, there's full name, and there's cited reference. All of the things that you have seen in the previous spreadsheet is in here. It's just that they have different tag names. All right, so there are a lot of different ways that you can use the information here in Web of Science and then get to a format that you would like to work on. Okay, so I'm going to click to close Citation. Okay, and close the ISI file, but please do remember that you will want to do it to save it as ISI file for the following sessions, especially for the network analysis ones. Okay. All right, so this is the feature that I'd like to share with you about saving the data set and how you can get the metadata from Web of Science. Okay, another thing is that there are times you want to save your record to Insights, because Insights is connected with Web of Science, and we have the privilege of using Insights to get indicators of like percentile ranks, journal impact factors of each of the journal and articles collected in this specific data set. So if you save that, Insights actually will automatically provide these answers in seconds. Okay. So you just save them to Insights. If you haven't done so, make sure that you have Insights access. Okay. I'm sorry. So you save them to Insights, and then Insights will ask you to have a file name. So let's say that I'll just name it as Vika, okay? And Insights has a limitation of 20 files. It doesn't really have to do with the file size, but have to do with the number of files. So you can update or save 20 files to Insights for them to do analysis. So make sure that if you have more than 20, you want to delete some or maybe save some ahead of time. All right, so once it is saved, they actually will send you an announcement or a reminder saying that how many of them have been saved, how many of them can be retrieved in Insights. Okay, so if you click on Insights, here I'm going to be asked to sign in again. It happens, so just be patient. Okay, so when I sign in that, you're going to click on My Folders here. Okay, so for the folders here, you're going to get the one that is Zika. That is what I have just saved. My hunch is that I'm not going to get a lot of information about it because Insights actually provide information for a shorter window, and Zika is something that is really new, so I just assumed that a lot of things will be cropped out. Okay, so let's see. Okay, so 1,500, not too bad. Okay, our data set was about 1,700. Okay, so it's only about 200 articles. So that's pretty good. All right, so I actually will be talking about Insights in a more detail in the future sessions. But again, I wanted to quickly show you what is available when we save data to Insights. Okay, so they will show you like what is the specific subject category, how many documents, the normalized citation impact, how many times it's cited. You can actually customize these things. Okay, you can browse the indicator, like I want to see how many of them are in the top 10%. Okay, or you can say that I want to add something about collaboration. How many of them have international collaborations? And you can see that there are numbers popping out here right now. Okay, so there are like more than 36% of the paper that have international collaboration patterns, have international collaborations in the field of infectious disease. Okay, more than 50% of the paper in the field of infectious disease in this data set are ranked as the top 10, so that's a very good number. All right, so you can get a lot of number easily, okay? But I also wanted to warn you that we also find that there are a lot of errors in Insights recently, and so do not just trust this number at a face value. I'll talk about them in more details later in other sessions. But still, I just wanted to show you that in its ideal situation, you can get a lot of a good number in indicators just seconds from Insights. Okay, all right. So these are pretty much what I would like to share with you about Web of Science. Okay, now I would like to switch to Scopus. But you can imagine that I'm not going to spend too much time on Scopus because a lot of the features are repetitive, and because I personally, or I would say that our team, the bibliometrics team, use Web of Science data a lot more than the Scopus data. Okay, so let me switch to sorry, Scopus right now. Okay, for Scopus, what do they have to offer? Basically, same thing, citation overview, basic analysis, and the metadata. Okay, so after you're done with the searches, you can analyze the results, you can explore them to get the metadata, you can view the citation overview. Okay, so very similar. For the citation overview, you're going to see something like this. Okay, so you can see that the citation of each of the articles, and then you can see how many citations they receive, and then if you click on the H graph, you will be able to see the H index. And again, if this is for specific author or the lifetime publications, that would be the H index of that specific author. But if you're looking at a collection of publications from an office, a group of people, it's not the average, okay? It only means that for this data set, 7 articles have been cited at least 7 times. So that's it. Okay. From the analyze results part, you will get something similar, okay? So you can look at the document type, you can look at the document per author, the affiliation, subject areas, and also by country, by territory. The major limitation is that they do not provide you with the flexibility of choosing the threshold. Remember, in Web of Science, you can pick you want top 10 or top 15, top 20, 25, 50, things like that. But in Scopus, it's always top 10. So you will only get the information or the graph of these top 10. Okay, so it's just about the ready features that they provide. For the metadata, remember, you are going to do the export, and then you can pick. They're going to ask you the kind of a format that you would like to pick. So if I pick CSV, the spreadsheet, okay, they will ask you that what are the fields that you would like to download or export, okay? And again, usually I just click everything, all right? If you are sure about the things that you do not need, you can just unclick them. And when you're done with clicking and you click export, and then there will be an Excel sheet. And remember, there's a limit of 2,000 records, okay? And after you're done, you're going to get something like that, okay? The tags are very straightforward. You don't really have to search because they tell you these are the author, the title, the year, the source, the journal, the DOI, affiliation. The affiliation is a little bit easier than the data that you get from Web of Science because you don't see the author name. But again, they still have all sorts of things lumped together, maybe starting from the child agency, the department, and then the university, and then the city, and then the country, or sometimes it's the agency and the department, and then the city and the country. So you still have to do a lot of cleaning, okay? And since their tags are very straightforward, I'll just leave it here for you to see. All right. Okay. One thing I like about Scopus, or I always start with Scopus, is when I have to do individual author search. A lot of the time when we are doing bibliometric analysis, we'll be asked to provide analysis on specific author, or to do searches on individual authors and then put them together. And you know how difficult it is to search individual authors when they have a lot of different ways to spell their names, or when they are when they have gone through a lot of different institutions. It can be quite challenging in doing that in Web of Science. You have to put in all of the possible variation of the names with or without middle initials, or if they use their maiden name, or after marriage, they change your name, things like that. Okay, so you have to consider a lot of variants. But one thing I like Scopus a lot is how they have tried to clean this data already. So this is an example about a researcher named Germaine Buck-Lewis. Okay, so you can see all of the various different variants of her names. Okay, so you can see that Germaine Ann Buck-Lewis is the formal or the way that she prefers. But there is also Germaine Buck, Germaine Ann Buck, Germaine Lewis with a hyphen. Okay, there is also G.Ann. okay? And there are a lot of different ways, and they can be from different institutions, all right? And if we get enough information from our clients, we will be able to easily consolidate these names together. So for instance, I know that this author was originally from NICHD, but then now she moved on to George Mason University. So I knew that all of these records belong to her. So I can easily just click them and then consolidate them all together and then to do analysis for her. So it's very easy for me to do this kind of aggregation, especially you know the affiliations of the author. I have to acknowledge that there are times they still made mistakes, but I think it's much easier to do that here in Scopus than to do it in Web of Science with search individual authors. All right. Okay, so I would like to quickly show you Scopus. Okay, so let's do do the same thing for Zika. Okay, and you can see that there are 7,000 something. Okay, and we have to do the same thing. Okay, let's say that we look at the document type. Scopus do not index meeting abstracts. So it means that you're not going to get meeting abstracts. Let me close this one. Okay, so you don't have to exclude meeting abstracts. But remember, we only select a few, so I'm going to select article, review, letter, editorial, conference paper. Okay, I'm just going to do that. And then I'm going to limit to, all right? So our number dropped to 6,000 something. And again, if we want to do the citation overview, we don't want to include anything that is too new, so I'm going to exclude these things. So now it dropped to under 2,000. So this is the time that you're, okay, make sure that you select all of them. Now the gray part becomes linkable, okay? So you can look at the citation overview. Okay, so you can see sorry, it takes a while to load. Okay, so here you can see that it talks about the H index of this file and talks about the specific citations they receive each year. Okay, let me go back to the results here. You can also do analysis on that. And remember, they basically provide you with these things already. Okay, you can click on that and analyze. You can also export it. So it's very easy to do as well. And then you can go back to, let's go back to the results. Remember that if you want to do further analysis, like more than 10 categories, okay, then you will have to, again, select all of them and then export them, okay? And because of the previous selection that I have done, they automatically download a CSV file for me already. If you didn't do it frequently, a window will pop up asking you the kind of elements that you would like to include, okay? So when it is done, and because luckily it is less than 2,000 records, everything will be included, all right? So I'm not going to show you because it's basically the same thing. You're going to see author, the fields, but you will be able to do a lot of cleaning and analysis on that, all right? So basically, these are the features that we usually get from Web of Science and Scopus. Okay, I'd like to quickly wrap up the summary, and then we can have some time for questions or maybe some quick practice. Okay, so this is a quick summary about Web of Science and Scopus. As I mentioned, that the coverage for Web of Science is that it goes much deeper. So whenever you want to do a historical review, like the past 30 years, 50 years, even, or maybe even 70, 80 years, you want to do Web of Science, okay? But if it is something that is newer, Scopus actually will give you better numbers in terms of maybe citation count, H-index. So for a lot of the newer or junior scholars or researchers, when they want to do their own review, I usually use the number from Scopus. They will get better H-index, better citation count. Okay. All right. Do they provide author name? Yes. Author name search, yes, but I usually prefer using Scopus for the author name search because of the cleaning quality that they provide already. Okay, for institution name, they both do that. Web of Science seems a little bit better than Scopus because of the unifying process. They also provide a country name, provide document type. For funding text, Web of Science is slightly better than Scopus. For the subject category, Web of Science provides more than 250 subject category, and in Scopus, it's very broad. It's like 22 disciplines. They also have something that is smaller or more detailed, but you don't get that from their website. I believe you will have to get that either through their API or through their other associated tools. Okay, for percentile ranking, you get that from Web of Science when you have access to insights, okay? And for Scopus, you don't get that unless you use their other tool like SciVal. For citation report, you get that from both of the tools. Web of Science is slightly more generous. If your data set is under 10,000, you'll get that. For Scopus, your data set has to be smaller than 2,000 records. And as I mentioned, you can slice your records and then aggregate them together to get your results. But their part of it can be quite challenging. Okay. Oops, it's gone. Let me go back to, can you still see me? Yep. Okay, sorry. They also provide H-index, and as I mentioned that for the newer publications or junior scholars, you will get better results from Scopus. Okay, citation count, you also get these from both of Web of Science and Scopus. And because of the way that the limitation of both data sets, you usually get better reports from Web of Science when you have slightly larger data sets, okay? And when you export the data, you can basically download everything from Web of Science. It's just you have to be patient, okay? 500 records a time. And for Scopus, the limitation is 2,000 records. Even when you are patient, you can still have some difficulty or challenges in downloading that. So this is sort of a quick summary about the two tools. All right. So now I think we still have a little bit of time. How about we just use, this search tool, this search string to do a little bit practice. I'm going to share it in the chat box so that you can copy and paste. Okay, so try to do the search in Web of Science and see what is the result you come up with. Okay, so go to the advanced search and copy and paste the search string. And the search string is something that we have come up with already. Okay, so this is for Fogarty and from the year of 2011 to 15. And here we have requests that we do not want any meeting abstract. Okay, so you can do the search here. So you're going to see 920 records. Okay, I still want to double check if the document type includes everything that is valid or legitimate. Okay, so there is a research article, editorial material, review, letter, book chapter, proceeding paper, correction, book review. Seems fine, as long as there's no other restriction stuff, that is fine with me. So we can use everything here, okay? Unless your client mentioned that they specifically want something or do not want something. So this is fine with me. There is also the publication years. Okay, so these are the years that we want. Okay, so it seems that this is a pretty good data set that I can use. What I always do when I create public reports for a specific data set is that I'm going to create a specific folder for that data set. I can show you that you're going to get tons of files for just one report. Okay, for example, this is the one that I did for NCCIH. And you can see that these are all the files that I need, okay, to create one report. So there are at least 20 files. And you don't want to lose any of these files. So make sure that you create one folder for each of the report that you would like to create. And make sure that you put everything together. Okay, so for this folder practice, you can create a folder called whatever you want to call, maybe just a Fogarty practice, okay? And then you can start with maybe downloading all of these things. Okay, so we can start by downloading the results. Okay, we'll start with 1 to 500. Okay, we want everything. And since now we want it to be ISI, okay, we just leave it like this and click send. Okay, so this is the first ISI file, okay? And then you are going to download the same thing for the second one. Remember, there are 920, and we only download the first 500. So the second time you're going to do that is that you're going to do the same thing here. You click on that. They don't allow you. It's fine. You click on other tags. Okay, close it, and then go back to here. Now it allows you to do that. Okay, starting from 501 this time, and then go to 920. Okay, remember you're going to select 4 records cited reference, and do not change anything here, and then download this one. Okay, now I have these 2 files, okay? The 9 and 10 are the ones that I have to use to to put them together. And actually it's pretty straightforward. You just copy and paste them. That's I wouldn't say it's the easiest way, but I think it's straightforward. You can also use other command line if you're familiar with that. Okay, so just pick whatever is familiar or is comfortable with you. So make sure that you go to the end of the file. Okay, and then paste them. And then now you're going to save the file as, okay, change it to all files, and then to Fogarty ISI. Okay, so this is a file that we're going to use in network analysis, in create a lot of other things. Okay, so I'm going to stop here and take questions. If you have any questions, I hope you will be able to either put in the chat box or to open up your mic. I'm not sure if you can do that, but try to put it in the chat box. And I'm going to stop the recording right now.